All right, you ready to do a bunch of examples for simplifying exponential expressions? Because I sure am. All right, let's do it. So we're going to start off obviously a little easier, and then we get harder. That's how math works, you guys know. So let's do y to the 6th times y to the 9th. I'm multiplying the same bases, so I add the exponents. So my answer for this one would be y to the 15th. 6 plus 9 is 15. For this one, it looks like I have an expression to a power. So I first ask myself, am I allowed to distribute that exponent? Absolutely. I don't have addition or subtraction going on. So when I distribute the exponent, it stays an exponent. So I get 2 squared times x. And then when you have an exponential expression to another exponent, a power to a power, you multiply the exponents together, right? So x to the 3 times 2 would be x to the 6. When you apply an exponent to just a regular number, just leave it as a regular exponent. So 2 squared gives me 4, so my final answer here would be 4x to the 6. Over here, we got a bunch of x's being multiplied together, so I'm going to go ahead and add all of their exponent pieces together. So I can do x to the -2 plus -6 plus 4, which, let's see, that would give me x to the -4th as my quote final answer. And then technically this negative this negative exponential expression is living on the wrong side of my fraction. My x to the -4th is already secretly over 1, right? So when it's living on the wrong side of the fraction, I'm going to go ahead and move it to the bottom. And then I have 1 over x to the +4th, because now it's living on the right side of the fraction. This 1 on top comes from the fact that secretly always there's a 1 that's always multiplying these pieces, right? There's a 1 multiplying up here. That could stick a times 1 out front here. So when I move the x to the -4th down to the bottom, there's still a 1 in the numerator, okay? All right, up here, right off the bat, I can cross off x to the 0 because I know that equals 1. So then I just have 8 x's on top and 12 on bottom. So where do I have more x's? On the bottom. How many more? 4. So 8 on top would cancel with 8 on the bottom, and I would just be left with 4 x's in the denominator. Again, you have to actually write in the denominator, like over x to the 4th, because there's always secretly a 1 multiplying out front of all of our exponential expressions. All right, let's do some more. Oh, geez. Okay, so over here, right off the bat, I see this y to the -3rd can get moved up here and live on the right side of the fraction. And I just have y squared left down there. Y cubed times y to the 5th times y cubed would give me y to the 11th on top over y squared. So then where do I have more y's? On top. How many more? 9. So I'll be left with just y to the 9th. If you want to write over 1, feel free, but you don't need to. In this one, can I distribute that exponent? Absolutely. I don't have any addition or subtraction going on. So when I distribute that exponent, I have an exponential expression to another exponent. I got a power to a power, so I'll go ahead and multiply those exponents together. So I'll have z to the 3 times 2, which would be 6, times z to the 5 times 2, which would be 10. So z to the 6 times z to the 10th. And when you multiply expressions that have the same basis, you add their exponents, so we'd end up with z to the 16th. Over here, can I distribute that exponent? Sure can, because you don't have any addition or subtraction happening. You gotta be a little careful on this one, because at the beginning this is a -2, so when I do -2 cubed, you have to make sure to include that negative as well. Okay? B cubed to another 3 as a power, an exponential expression to an exponent is a power to a power, so I go ahead and multiply those exponents together, so it'd be b to the 9th, and then same thing here, b cubed to another power would be another b to the 9th, and then when I actually do -2 cubed, you can do it in your calculator or you can do it in your head. It means do -2 times itself 3 times, so I actually get a -8, and then b to the 9th times b to the 9th while I add those exponents. So I get b to the 18th. All right, let's go ahead and do this next one. So in this one, my cube, first and foremost, is applying to this quotient, but that's okay, and I can go ahead and distribute because I don't have addition or subtraction happening in there. So I'll just have 3x to the 4th times On top, it'll be x to the third. Secretly, this had a 1 exponent, right? So 1 times 3 is still 3. And on the bottom, I have 3 to the third. And let's see, I can write this as over 1 technically, right? So then I can kind of combine those. I'll have 3x, x to the fourth times x to the third would give me x to the seventh. And then on the bottom, 1 times 3 cubed. Remember when we multiply fractions, you multiply straight across the top and straight across the bottom. Would just be 27. Yeah, 3 times 3 times 3. Yep, 27. And then the last thing you have to be able to do is you have to be able to reduce that fraction if you can with the coefficients. We haven't dealt with a problem yet that's had 2 numbers in it. So when you want to reduce the coefficients, your numbers, you can go ahead and do in your graphing calculator. I'll just write it down here and then I'll erase it. So you can do 3 divided by 27. And when I do that, I get 0.1 repeating, but we don't want decimals, especially repeating decimals, because those aren't exact, right? They're only just approximations. But then once you get this, if you hit math, enter, enter, your calculator should spit out for you the most reduced form of this fraction. So then if I hit math, enter, enter, it tells me my answer is 1/9. So then I'll have my 3 over 27 reduces to 1 over 9, and then I still had that x to the 7th in the numerator. Beautiful. Do you technically need that 1 there? No, but it's okay if it's there. All right, let's go ahead and erase these, and then we'll work on these next problems as well. Okay. So these ones are, I think, going to require a little more work, so I gave you a little more space to work with them. Okay, first and foremost, so I see some exponents applying to fractions, or excuse me, applying to parentheses, so I'm going to have some distribution if possible. I don't see any addition or subtraction anywhere in here, so this square only applies to the left-hand set of parentheses, and then this cube applies to the right-hand set of parentheses. Remember, when you are distributing that square, it means you're doing the number -3 squared, and then when you have an exponential expression to another exponent, you have a power to a power, we go ahead and multiply those powers together. So x squared squared gives me x to the fourth. All right, and then on this side, it's still just multiplication happening. You have 2 being cubed. Why did I put the parentheses around here and not around here? Because this is a negative. I want to make sure to remember to include that when I'm going to square it. 2 we don't have to worry about because it didn't have a negative. And then same thing going on here with my power to a power. So I go ahead and multiply those, and I get x to the -6, -2 times 3. Okay, let's see. -3 squared is 9, x to the fourth, and then we got times 2 cubed is 8. And then x to the -6. I'm going to go ahead and, because my negative exponent there, I want to move it down to the denominator. 9 times 8 is 72, x to the fourth. And then because I moved this guy down to the denominator, I ended up with x to the +6 now on the bottom, because now it's on the right side of the fraction. And where do I have more x's, top or bottom? Well, I have more on the bottom. How many more do I have? 2 more on the bottom. So my final answer should be 72 over x squared. Nice. All right, up here, automatically, I see that I have x to the -4th and y to the -2. So I'm going to go ahead and scoot those. Oops, I've been doing that in pink. I'm going to go ahead and scoot those to the numerator up there. My 7's still going to stay down there though. My 7 doesn't have any exponent on it, so it's where it's supposed to be. So I'll have xy, x to the fourth, y squared, all over 7. And then now you can multiply the like bases, or bases that are the same. So x times x to the fourth, these secretly have an exponent of 1 on it. So x to the first times x to the fourth would give me x to the fifth. Oops. And then y, technically to the first, times y squared would give me y to the third, all over 7. Then you're done. All right, up here I see that I have this cube that's applying to every piece in here, so I'm going to go ahead and, because I only have multiplication occurring, I don't have addition or subtraction, I'm going to distribute that cube. So I end up with w cubed times 4 cubed times w, a power to a power, so you get w to the 6 times a power to another power, w to the 6. And then now I have w cubed, w6, w to the 6, and w to the 6. So when I multiply all those, I add all their exponents together. So I get 12, 15 w's, so w to the 15th. And then 4 cubed means do 4 times itself 3 times, 4 times 4 times 4, and I get 64. All right, I got 3 more here, and then we'll stop and take a little pause. So on this one, I have only multiplication and division happening, so I can go ahead and distribute that exponent to every piece that's in there. So I'll get 2 cubed, and then a power to a power means you multiply your exponents. So y to the 4th squared gives me y to the 8th, all over 4 squared. And then y's got a secret 1 here, power to a power, gives me y squared. All right, and then we get, let's see, 2 squared is 4, y to the 8th, over 4 squared is 16, y to the squared. And it looks like I can reduce my 4 over 16. Again, if you want to do it on your calculator, do 4 divided by 16, you'll get 0.25, and then hit math, enter, enter. And then that tells us that we reduce our fraction to 1/4. And then where do I have more y's? On the top, how many more? 6, so I'm going to end up with just 6 y's on the top. All right, and these ones, I'm going to go ahead and distribute and distribute. The 5 only applies to the left side of parentheses, and the 3 only applies to the right. So I have x to the 5th over y to the 10th, because I'm multiplying those exponents, times x to the 6th, y to the 9th, all over z to the 6th. Right? Yeah, okay. Let's see, I got x's right here that I can multiply. When we multiply, we just go straight across the top, so you can just combine everything that way. So I have x to the 5th and x to the 6th, so it would give me x to the 11th. And then you can just treat it now as like one giant fraction if you want, right? So I have 10 y's on the bottom and 9 on top, so where do I have more y's? On the bottom. How many more? 1. So I end up with 1 y on the bottom, and then my z's are just hanging out. So that would be my final answer for that one. All right, last one before this video ends. So I'm going to go ahead and distribute that -3 exponent to every single piece because there's only multiplication and division happening in here. There's no addition or subtraction, so feel free to distribute that exponent. 2 to the -3rd, this was an x to the -1, so a power to a power. -1 times -3 gives me a +3. And then y to the -3rd now, because it secretly had just a 1 up there. X to the -3rd to the -3rd, you do -3 times -3, which gives me a +9. And then y to the -2 to the -3rd gives me y to a +6. Let's go ahead and we're going to move our pieces with negative exponents to where they belong. So then I have, the only thing I have on top is an x cubed down, and then I have 2 to the +3 in the denominator, x to the 9th, y to the 6th, and y to the +3 now. All right, some things I can simplify. 2 to the 3rd is secretly 8. Where do I have more x's, top or bottom? Bottom. How many more? 6 of them, so I have 6 down there. And then I have y to the 6th times y to the 3rd, so then you add those exponents, so you get y to the 9th. Good math. And then what's secretly left up here? The number that's always left up there if there is nothing, no variables and no other numbers, well, it'd be a secret 1 that's always multiplying up there. So that'd be your final answer for that example. All right, go ahead and pause. Make sure you have all this down, and then we're going to go ahead and do some more examples.